All right, now we're going to look at higher order derivatives. So that just means doing the derivative more than once. So if this is our original function here, call it y. If we do one derivative, we're going to call it y prime. And we can actually do more derivatives. So I'm going to do the second derivative, so I'll call it y double prime. And on the next example, I'm going to plug a number into that. So here's the next example. As you can see, we're going to plug a 1 into our final answer. So on the previous page, we found the second derivative evaluated for any value of x. We want to know what is the value of the second derivative when x is 1. So we're going to write that as y double prime of 1 final answer is going to be 390. Okay, if you remember from pre-calculus, we did powers of I. So I was the square root of negative 1. That just gives you I. I squared is the square root of negative 1 squared, so you just got negative 1. I to the third, and that gave you negative I. Now here's where it gets interesting. I to the fourth gives you 4 square root of negative 1s multiplied together, and so you end up with just 1. And then that pattern just repeats. So I to the 1 gives you the same thing as I to the 5. I squared gives you the same thing as I to the 6. I to the third, same as I to the 7. I to the fourth gives you the same thing as I to the 8th. So we notice this pattern that every time you get I to the fourth, it cancels to 1. And the reason why I'm showing you this is because we're going to do higher order derivatives, and the same thing happens to sine and cosine. After 4 derivatives, you're back to the start. So let's say we're going to do a really high number, like I to the 202. So I to the 202 can be broken up into I to the 200 times I to the 2. And I to the 200 is I to the 4 times 50. And that's important because we know I to the 4 is just a 1. So we end up with 1 to the 50, which cancels. And our final answer is really just I squared. Remember, I squared is just negative 1. Again, I'm just showing you this because when we do the derivative for sine and derivative for cosine, a similar thing happens. Let's have a look. This would be the 202nd derivative for the function sine of x. Now, if we did the first derivative, we get cosine. The second derivative is negative sine. The third derivative is negative cosine. And the fourth derivative, we're back to sine. And that's going to repeat. That's a pattern. So what that means is the 200th derivative would just give you sine. We need the 202nd derivative. So we do one more. Derivative of sine would give you cosine. Now we're at the 201st derivative. Let's do one more. The derivative of cosine is negative sine. Now that's the 202nd derivative. Final answer was negative sine of x. Now you don't want to do 202 derivatives. That would take forever. And that's why we're looking for this pattern here. We started with sine. And every 4 times you do the derivative, you're back to sine. Remember, 200 is 4 times 50. That's a multiple of 4. And that's why we're back to the original sine. Again, we wanted the 202nd derivative, so we did one more. That put us at 201. And then we did one more after that. And that got us to 202. I also want you to take a look at the notation. This is the first derivative. This is the second derivative. This is the third derivative. And usually after that, they put it in parentheses. So that's not f to the 4th power. That's the 4th derivative. And this up here is the 202nd derivative. Okay, what if it was a 5x instead of just an x? Well, the first derivative would give us cosine of 5x, but then we'd have to do the derivative of 5x, and we get an extra 5. We do another derivative of cosine of 5x is just going to be negative sine of 5x, but then we have to do the derivative of 5x, which gives us a second 5. So now we have 5 squared. Then we do the derivative again. Derivative of negative sine is going to be negative cosine, but because the inside was 5x, we have to do the derivative of 5x. It gives us another 5. And we do it one more time. The derivative of negative cosine gives us sine, but the inside wasn't just an x, it was a 5x, so we have to do the derivative of 5x, and we get another 5. So we keep getting these powers of 5. For the first derivative, it's 5 to the 1. For the second derivative, it's 5 to the 2. For the third derivative, it's 5 to the 3. For the fourth derivative, it's 5 to the 4. By now, I think you can see the pattern. For the 200th derivative, it's going to be 5 to the 200. Again, we want the 202nd derivative, so we do one more derivative. Now we're at 5 to the 201. Derivative of sine is cosine. Now we need to do one more derivative because we're looking for 202. Derivative of cosine is going to give you negative sine, but again, we have to do the derivative of 5x, so we're going to get one more 5. Now our 5 is to the power of 202. So for these derivatives, it's a matter of noticing the pattern. Okay, here they want us to find the second derivative of f and evaluate it when x is 3. So first we're going to do the first derivative, then we'll do a second derivative, and lastly we'll plug in x equals 3. Here's our function. It's x to the 10 times g of x. So we're going to have to do the product rule. So f prime of x is going to be 10x to the 9. And then g prime of x times x to the 10. So that's the first derivative, but we need the second derivative, so we're going to have to do one more derivative. Now, when we do the derivative of each of these two pieces, they're both going to be a product rule. So here we go. Second derivative. Okay, I'm going to do this one first, and I'll do it in green. Okay, then we'll do the derivative of this piece. I'll write it with blue. Almost done. Now we got to plug in the 3. Okay, we can see here that g of 3 is 4, so we're going to want to plug that in. We can see g prime of 3 is 5, so we're going to want to plug that in. Okay, you can see g double prime of 3 is 10. Remember, you don't have to simplify simple arithmetic. So we can leave our final answer like that. And if I was giving you this for the test question, I would probably have you plug in a 1 instead of a 3.